let us see the applications of PCC. So PCC oxidizes primary alcohols to aldehydes, secondary alcohols to ketones. So here I am taking a primary alcohol which is oxidized to aldehyde, and means you can clearly observe the number of hydrogens are getting reduced. So removal of hydrogen is also called as oxidation. So PCC helps to oxidize a primary alcohol to aldehyde. So in this process you can observe the byproducts chromous acid and pyridinium chloride. So now you can observe the mechanism of the process reaction. So I am taking a primary alcohol, I am taking a chlorochromate ion from PCC. So what I am doing first, I am shifting the C double bond O bond, that means CO bond, towards oxygen. So the pi bond is shifted towards oxygen. So oxygen getting a negative charge, chromium gets a positive charge. Now lone pair of electrons present on the oxygen are attacking on the positive charge of chromium and forming a new bond between oxygen and chromium. So you can see oxygen and chromium forming a new bond. Okay, so now you can observe this O gets a negative charge. Okay, as oxygen donated electrons, it is getting a positive charge. So next what happens? Next I am shifting the oxygen hydrogen bond, the bond present between the oxygen and hydrogen, towards oxygen. So as oxygen positive charge is there, we should nullify the positive charge. In order to nullify this positive charge, I am shifting the paired electrons towards oxygen. So this hydrogen can be liberated as positive ion. So now this O minus of chromium attacks on the H plus and forming a OH bond. Okay, so now this positive charge is nullified. So we can see the third step here. I am removing the chloride ion. That means in order to remove the chlorine in the form of negative ion Cl minus, I am shifting the bond of chromium and chloride towards the chlorine. So the chlorine gets a negative charge now, and whenever here you are shifting the bond, chromium gets a positive charge. This positive charge and the negatively charged oxygen forming a double bond here. Okay, so here there is a formation of double bond. This double bond results in the chromate ester formation. So next what I am doing, next I am cleaving the bond between oxygen and chromium. So shifting the bonded electrons towards a chromium. So whenever you are shifting this bond, I am shifting this bond also, double bond, pi bond between chromium and oxygen towards oxygen. So whenever you are shifting the bond, oxygen gets a negative charge and this bond is cleaved. Okay, so this negatively charged oxygen attracting the hydrogen from this carbon. So in order to make the positive hydrogen as positive one, I am shifting the bonded electrons towards carbon. So carbon gets negative, this oxygen is already having a positive charge, both are getting a double bond, this double bond. Okay, so this hydrogen is now reacted with oxygen, oxide O minus ion, and forming a OH bond. So this one is coming out as a chromous acid. And next what happens, this Cl minus reacts with a pyridinium ion which is present in the mixture and coming out as a pyridinium chloride. So this is a mechanism of conversion of primary alcohol to aldehyde by using PCC.